Hi guys, today we're going to look at chapter 4 on congruent triangles. And this chapter basically covers everything about triangles. And if anything, I personally think that's really one of the most important parts of geometry in 8th grade. So let's get into it. First, let's look at some basic triangle sum properties. So there's three main types of triangles looking at the sides. And as you know, equilateral triangles have all equal or congruent sizes or lengths, and an isosceles triangle has two equal sides, and a scalene has all different side lengths and no congruent sides. And note that here, isosceles triangle, many people think it's just two sides, but it's at least two. So an equilateral triangle would also be considered an isosceles triangle. You should probably recall that. And next, looking at the angles. So acute triangles are triangles with three acute angles. So I think angles that are less than 90 degrees. And a right triangle is a triangle that has at least 1 degree that is right or is 90 degrees, and with everything else being acute. And an obtuse triangle is a triangle where there's one obtuse or an angle greater than 90 degrees, and an equal angular triangle is where all of the angles in the triangle is the same. So in this case, it would be probable that they're all 60 degrees, given that the sum of the angles of a triangle is 180 degrees. I think these are pretty straightforward. But something that is important to note here is interior and exterior angles. So you'll probably use this a lot when you do proofs later on that are more advanced. But first, you must know that interior angles are angles that are basically like when they're extended, they're inside. So interior would be like if this is a triangle, they're all interior angles. But exterior is if you like, for example, if there's a triangle here and you assume that all the lines are infinite, like something like this, and like let's say like this, then this would be an exterior angle. So it's an angle outside of the triangle that's met with the lines when the sides of a triangle are extended. So that's an exterior angle. Triangle sum theorem is the idea that all the angles in a triangle will add up to 180 degrees no matter what. And that's basically just a rule of triangles. And this is the proof for the triangle sum theorem. So it's really pretty straightforward, but you just first draw the parallel postulate, and as you should probably recall, the angle addition postulate. So that's adding angles, right? And alternate interior angles theorem shows that in this case 1 and 4 and 3 and 5 are congruent because that's how alternate interior angles work. So if there was a line like this, that's how it basically work. And then you know the definition of congruent angles. So remember that congruence is the same as equality, it's just called something different. And here lastly, you substitute the angles to show that they add up to 190. And next is the exterior angles theorem. And this shows that the measure of angle 1, which would be some exterior angle outside that augments angle C, or whatever angle here alone. And they would then the angle measured 1 would be the same length as the sum of the two other angles in the triangle except for C. So that would be in this case A and B. That's just what the exterior angle theorem says, and this is pretty easy. And this is corollary to the triangle sum theorem. So you have to remember that a corollary is something that is kind of augmented and is really similar. So it's not a totally independent theorem, and it's kind of contingent on a previous theorem. In this case, it's corollary or it is contingent on the triangle sum theorem. And here it's saying that acute angles of a right triangle are complementary. So if there's 90 degrees angle, the other 2 degrees that are acute add up to 190 degrees. So if we just look at classifying triangles, we know that this is not only this, let's look at number 9. So this is equilateral. At the same time, you have to know that it's also isosceles because it has at least 2 equal side lengths. So if you look at 16, for example, by the exterior angles theorem, 64 plus 70 would be equal to angle x. In this case, that would be 134 degrees. And here, if you're trying to find exterior angles, it would also work the same way. In this case, 3x plus 2 plus 90 degrees is a value is equal to x plus 90. would be equal to 180 minus x, and 3x plus 92 would be 4x, 92, 8. Oops. Sorry about that. And that would be 22. And that's really how it works. And it's really honestly pretty straightforward. There isn't much like to this, honestly. And you have to know that when you're finding the answer for these kind of problems, you have to know like and refer to previous theorems as well, because they all are like they all connect. But now let's move on to 4.2. So applying congruence and triangles. So if it's congruent, it's the same size or shape, and non-congruent is just not that, right? And when you think of congruence, there's two main statements you can make. Remember, congruence is the same as equal, but it's just used as it's just a geometrical term to refer to the same thing. And by corresponding angles, then you're referring to basically the angles are equal, but you use the congruent sign here. And if you're saying that they're corresponding sides, then you're saying the sides are equal. And remember, when you're using corresponding or congruence, you do this sign, but when you say equal, you use this. And you have to note the difference here. That's essential. And these are honestly really straightforward, but let's look at this theorem. So the third angles theorem. Basically, if there's two angles of a triangle, then if two angles of a triangle are congruent to two angles of another, then the third angles is also congruent. And this logically would make sense, because if A, B, let's say A and D and B and E are equal, and let's call this 45 degrees, and let's say here is 60 degrees. And if you think about the triangle sum theorem, which is that it adds up to 180 degrees, subtracting 180 degrees by 105 in this case would always give the same value. So that's how it's really algebraically proven. But let's look at three properties. So these properties, you've probably heard of the reflexive property, symmetrical property, transitive property a lot, but it's important to note that it's used differently depending on the situation. And if it's congruent, it's used for congruence. If it's for equality, it's used for equality. So just to review, reflexive is that it's equal to itself, or in this case, it's corresponding to itself. The triangle ABC would be equal to triangle CBA would be the same statement here. And that's really what the reflexive property of congruent triangles is saying. And the symmetrical property is saying that if x is equal to y, then y is equal to x. In this case, it would be if x is congruent to y, then y is also congruent to x. And last, the transitive property is forming basically like a link. I like to call it kind of like a bridge, right? So if there's if the ABC is congruent to DEF and DEF is congruent to JKL, then obviously ABC and JKL are congruent to one another. Here, if you're trying to find the value of x, because you know that 80 plus 45 plus 5x is 180 degrees, you can solve this by just solving it. So x is 11, and here the value would be 55, right? Also, these problems are not very difficult, but before we end for today, if you just look at one last proof here. So here, what the proof is saying that AB and ED are symmetrical, and BC and DC are also symmetrical, and at the same time, AC and CE are symmetrical. And here's also gives that the angles BC and CED are congruent. So that would be first the given, right? Next, when you're showing that BCA and or DCE, ECD, that's the same thing, are congruent, then you're using the vertical angles congruence theorem from, I'm pretty sure, 2.7 or just something, we're in chapter 2. And remember, this is not a postulate but a theorem. And you would use the third angles theorem to show that angles, because you've proved that these two are congruent, angle ABC is congruent to angle EDC, given basically the characteristic of triangles. And as a result, you can show that ABC and EDC are congruent, and that would just be because of the definition. This could be like the definition of, say, congruent triangles. And also this part could be definition of triangles, definition of an equilateral or equiangular, or the definition of a regular triangle would also work. Would all be something that works to prove that these triangles end up being congruent. And that's it for today. And next time we'll look into the famous congruence postulates, so SSS followed by SAS, ASA, the HL theorem later on, and the AAS theorem, which are all important theorems for triangle congruence. So stay tuned, and thank you guys. Bye.